And I will go check and make sure that this is posted online. Which it should be, but suppose it is what it is. Just gonna make sure. I've had some issues with this thing not live streaming correctly, so I have to keep checking to make sure it's good. Last week I couldn't live stream any of our lectures, and I tried both days. So apparently today it's working. All right. So what I wanted to discuss today is last time we began talking about, well, we continued talking about the engineering design process. We were talking about problem framing. And the goal of talking about problem framing was if you can frame a problem correctly or well, you can generally come up with a list of solutions that can satisfy what you're looking for. Okay? So the problem framing section is really integral to defining different types of problems. Today we're going to talk about ideation. And the thing about ideation is ideation gives you the ability to take what you've developed in a problem framing section and really pull something out of it. Okay? The goal with ideation okay, I'm still in the frame. The goal with ideation is you start by identifying all possible solutions. Okay? Now, not every solution is a good solution. I told you I like using the example of the light pole. Well, the light pole is, to me, it's powerful because a light pole doesn't solve every problem. In fact, it solves very few problems. So, if one of your solutions can be solved with a light pole, you gotta run that out, throw it away. So we start with all possible solutions. We then apply your measures of quality, which I'm just gonna abbreviate as MOQ. Measures of quality is something we discussed in the last lecture. You apply your measures of quality, you assume traits for each of your possible solutions, and then at the end, you choose 1 to maybe 3 viable solutions. Okay? You may pick more than that depending on your budget. You may pick 1, also depending on your budget. The idea is when you're done with the ideation phase, you have 3 solutions that you can then plug into the realization phase and start building and modeling and coming up with. What in the world? Is that milk?
No.
Why are there air bubbles?
Yes.
Yeah, that's good.
Interesting. Sorry, I left my inner foodie out in class. Okay, so this is the overall goal of ideation. Okay? Problem framing, you identify a problem. Ideation, you identify all of the solutions. Realization, you create 1 to 3 of them. Or more, depending on your budget. Or only 1, also depending on your budget. So, when it comes down to it, this is an integral step, but it's kind of a unique step. If you did your problem framing well, you will come up with a definition for what it is you're trying to create. Remember, that's the constraints and the functional requirements together collaborate to create a definition of the problem you're trying to solve. Okay? The measures of quality will tell you how good of a fit something is, but really it's that measures of quality, well, it's the constraints and the functional requirements that collaborate to define the problem. So as an example, okay, let's say I am trying to take a thermal measurement. This could just be as simple as I need to know what the solution temperature is. I need to know what this is. Now we're going to take a step back rather than just let's grab a thermometer and measure the temperature. We're going to take a step back and say, well, can we look at this in a broader scope? If we need to take a temperature reading, and we need a tool that is going to sense the temperature for our temperature reading, then what you may say is your functional requirements. That's kind of really important. Okay, so that's pretty much the obvious one. It has to measure temperature. But sensors do a little bit more than that. Right now, your skin is sensing temperature constantly. You have the ability to detect ambient temperature. You're actually measuring the temperature of your clothes, your shoes, your pants, everything, or shorts if you decided to wear shorts in the winter, near winter. It's November, Ivana.
It is very hot.
You guys are wearing jackets. Oh, all right, that's fair. I did go outside in a short-sleeve shirt, and it was really reasonable. But you are constantly measuring the temperature inside of your clothes because you have sensors active. Okay? All of those sensors have to do something with that information. Most of the time, we ignore our temperature sensors. Why? Because as I'm sitting down here, I'm not too cold, I'm not too warm, I'm doing all right. I don't need to know what temperature it is. So your body just says, well, that's useless information. We will check that out the window. So whether or not it's useful requires a little bit of processing. Okay, the sensor simply cannot say, it's warm, it's hot. It can't really give you that information without you having to do some data interpretation. Sensors don't speak the same language we do. So we need kind of an interpreter, and that's what our processing does. After it processes this information, it has to output this information somehow to you, so you can know what this is. There's no sense in reading a measurement if you're not going to do anything with it. Okay? And then lastly, there has to be some element of control. Sometimes that comes in the form of being able to remove error. Sometimes it comes in the sense of, well, when does it take a measurement? When does this occur? But these are the four functions that I can think of off the top of my head for a temperature sensor. That's the functional requirements. Constraints. Now, some of the constraints I'm going to put on this are going to completely change the problem. As of right now, I could have a room-sized temperature sensor that we just build into a room that senses temperature. There are needs for systems that are fairly large. We don't really need those. So I'm going to go ahead and I'm going to call this, it needs to be portable. Has to be something you can carry around. Okay? This has to be something that provides a continuous data stream. It's not something where you just throw it away afterwards. It's well, measure the temperature once, get a new one. As we define this problem, what else do we need it to do? Well, it can't be toxic. That's kind of important. Or explosive, or corrosive, or caustic. And more than that, it has to have a minimum impact on the measurement. If it requires you to spray a gallon of water into something, the temperature it's going to be reading is going to be the temperature of that gallon of water, not whatever you're trying to read. So that would have a huge impact on the measurement technique. Even then, every time you touch the tip of a glass thermometer to something, there is a heat transfer from the solution you were trying to measure to the glass thermometer. That happens naturally. And we're going to define temperature reading device based on this. It does these things, and it has to abide by these principles. Okay, we've now defined temperature sensor. Okay, so what I'm going to do in order to come up with a solution for this is I'm going to go ahead and I'm going to break out each of the functional requirements, and then we're going to talk about certain things that satisfy those functional requirements. Okay, so measures temperature. One possible solution to this is a glass thermometer, which uses an alcohol solution. The alcohol solution expands in the presence of heat, and you can measure that expansion. The reason why they use alcohol solution is because an alcohol solution doesn't freeze at sub-zero temperatures. They used to use mercury, but that's not healthy. Not as much as people think. Okay? Then you also have temperature sensors like thermocouples, which those are pretty standard. You could use a thermistor. We could also use an infrared sensor, something that detects the infrared radiation off of a subject or an item. There are a bunch of different types of temperature sensors, contact, non-contact, fun things. Okay? As of right now, I'm just going to leave it at these three. All right? So the next step is it has to process the information. Okay? Well, what kinds of things, what does process mean? Well, it means it has to take the information and convert it into something useful. This can be a computerized process. You read something in directly to a computer. The computer is able to adapt based on what you program into it. It reads the voltage, outputs something based on the voltage. Okay? You can also build a physical system. Physical systems are nice because then they don't require voltages. Computers run off of voltages. That's how you send any information, is through a voltage that eventually gets broken down into some kind of a binary number. A physical system doesn't require that and can actually have sometimes a higher resolution than a digital system. Now nobody uses what? Yeah. Yes. Everything. Until we come up with quantum computing, in which case then we no longer need binary systems. But quantum computing right now is just it's a theory. Some people have come up with some prototypes that are really interesting, but nobody's been able to mass market anything yet. So these are going to be really your two kind of processors. You get information, you spit it out. Output to user. Okay, one of the methods of outputting to the user is having some kind of a screen. a digital display. And the other methods of outputting the user is you have a dial or a physical thing that goes up like this, or a reading that you can take just by looking at it. Okay? As far as control goes for this device, being able to take multiple measurements, it may require having mobile parts. You know, like such as a temperature, a thermometer, you move it. You simply move it to control it, which that's not a very good control mechanism, but that's a different point. You can have a digitally initiated measurement. So you push a button and it controls when it is, that says digital initiation. You can't even see it at this point. I'm sorry. I'd write over here, but I could write over here. I will write over here. All right, so we got control. I just forgot what I wrote. But mobile parts, thank you. Okay, you can have digital initiation. Or you could even have just a manual push switch. Okay, push a button and do it. There's a bunch of different ways that you can control these too. So, of this system that we now have, we have multiple different forms that all satisfy these functions. If I wanted to come up with a solution, all I have to do is grab one out of every single category. One out of each function. Something that does that function, put them together, I will have a temperature sensor. Okay? Now I may have to get creative when I do put them together, but that's the point.
Alcohol solution with computer.
Huh?
It's an alcohol solution with computer.
You can do it. You can do a flow sensor. Or you could have a volumetric sensor. You could have it be involved in a linear potentiometer. There are a number of ways to digitize an alcohol thermometer. Unfortunately, when you get down to it, the alcohol thermometer is not nearly as precise as people wish it would be. So there's no reason to do it. But you can. It is a solution. Okay? So we take an alcohol solution. We put a computer. So the computer reads it. The computer outputs the information directly to the screen. And if we want to take another measurement, all we have to do is just move the thermometer. We get a constant data stream of what that alcohol solution thermometer is telling us. Okay? That is one solution. It's not a good solution, but it is one. My next solution, I take the alcohol solution. No, I take a thermocouple. I hook it into a computer. It outputs to a screen, and if I need to get a different value for it, I just move the thermocouple. That's solution number 2. Solution number 3, I have an infrared sensor connected to a computer, outputs to a screen, has mobile parts. If I need to take another sensor, I just move it around. Okay, so that's solutions 1 through 3. Solutions 4 through 6 involve switching these 3, but instead using a physical system with a screen and mobile parts. Solutions 7 through 9 involve using a computer and a dial output instead of a screen with mobile parts. Solutions 10 through 12 involve using a physical system to process and a dial with mobile parts. Solutions 13 through 15, it's the same thing, it's just with digital initiation. And we can keep going. This becomes something that we develop the total number of solutions just by combining these parts together. As long as we have listed out every possible way that we can do processing, every possible way that we have to measure temperature, every possible way of outputting information to a person, every possible way of controlling that, as long as we have filled those out and our definition is correct, These are the total solutions to your problem. That is the list of every one of them that is possible. Okay? It's not as hard as people think it is. Coming up with ideas for solutions is this simple. Understand what satisfies your little itty-bitty pieces and put them all together to form a full system. Okay? So what we're going to do in class today is I'm going to give you a definition, and what I want you to do is work through what could satisfy the functional requirements in the context of the constraints. Now notice all of these require, or they all fit in the constraints, which is why I didn't include mercury up there, because it can't be toxic.
Non-toxic mercury.
It's the safe for kids kind. They just add water to it like Elmer's glue. Yeah, so as long as it does not violate your constraints, but it fits within the context of your functional requirements, it is a viable solution, even if it's a terrible solution. Okay? Technically, as a temperature sensor, you can actually use, light. If you shine light through something, you can detect its temperature based on how much light that substance absorbs. So that could be your sensor, and that's totally possible. I didn't put it up there because I only drew a short list. But you could have added any number of things so long as they are not toxic, so long as they provide a continuous measurement, so long as they do not impact the measurement significantly, and it is something you can move. Then you can say anything. All right. So what I want you to spend the next 10 or so minutes doing is I would like you to take this definition of a problem and come up with an idea. Okay? I am creating an off-road vehicle. Okay? Now, the off-road vehicle, the functional requirements for an off-road vehicle are: it must move. If it can't move, it's not a vehicle. It must carry at least one passenger. Okay? And it has to be powered in part or in whole by an external power supply. Right? Like an engine or a battery. Not like you have to push. Okay? And I'm going to put one more functional requirement on here. This has to be able to jump or bounce over holes. Just be able to clear small, I guess, hazards, tree stumps, buildings. It has to be able to jump. It has to be able to climb, get over this device. Okay? So those are the functional requirements. As for the constraints, we live in an environmentally conscious world. We're going to say for this project, for this assignment, has to use renewable energy. It is not a viable solution if it does not use renewable energy. Okay? We'll say it has to be relatively low cost. And by that, I'm going to say less than $100,000.
So we're just making the Tesla truck.
Huh?
I'm making the Tesla truck.
I mean, you could. It does satisfy the constraints. And let's say another constraint is it has to have a top speed maybe around 35 miles an hour or more. Okay? All right, I'm going to give you 10 minutes to come up with ideas, and we'll talk about what kinds of ideas you have that satisfy this. You can go through the ideation process and pick one that you feel is best. And then for the live streamers, I'm going to sit here for 10 minutes and stare at you. You're coming up with an idea for something that will satisfy this definition of a problem. I didn't give you measures of quality because I think that adds an element of complexity to this. But ultimately what we would do is we would combine all of the ideas that we have, evaluate them relative to measures of quality, and pick a best idea from that. So we'll get back together around 2:38. And then I got some fun stuff to show you. Can't be toxic. Well, no, actually that's not a constraint up here this time. You can use nuclear power. It is clean energy. Just think. Just come up with an idea. Yeah, this isn't something you have to hand in. Normally I have people talk amongst groups, but I'm not even allowed to go sit with somebody and talk to them. So it's one of those more like, all right, just sit by yourself and think about things. You got the best idea? All right. Let's wait at least another 8 minutes or so. I'm going to go grab something that allows me to project on the screen. what are things that you came up with that would be good off-road vehicle concepts? Jeremy.
Quadcopter powered by hamsters and wheels. It's an actual off-road vehicle.
It is an off-road vehicle. It would cover rocky terrain.
Hamsters keep breeding, and you never have to pay for energy.
Might have to feed them at some point, but yeah.
We'll have grain growing on board.
Oh, there you go. Duncan?
Electric boat.
How does it jump?
It can jump waves in the ocean. Pretty exciting.
It is off-road. That's a good point.
I probably should have written that it actually is supposed to go over land.
Well, you didn't say that.
You just said off-road.
It's not on the road, it's on the water.
All right. Okay. Does anybody have some things that are on land? Yes.
A car with tracks rather than wheels that uses hydrogen combustion engine.
Okay. Any other ideas? You already gave one. You used your one idea. Zane, you got an idea?
Yeah, what about a horse?
Can a horse run 35?
Yeah.
Electric dirt bike.
Electric dirt bike would work.
How fast could you get a tire rolling down a hill?
Just a dude in a tire.
You'll go right over those bumps.
Wow.
Yeah.
Horses are
Boy, you may not recover from that though.
Put a helmet on.
They didn't die in grown-ups.
That's true. Although that does require that the external power is supplied by gravity. But it is external power. So, just something that's really fun to peruse on the interwebs, at least in my opinion, is really terrible inventions. Because the thing is, we can't talk about ideation and we can't talk about a number of solutions to this without bringing up the fact that sometimes you go through the engineering design process, you identify a problem, and the solution that you come up with is not good.
It's no solution.
What we could do, we
It-
could infiltrate Area 51,
Yep.
take the alien ships and use their electromagnetic field alien crafts to fly around on free electricity.
I mean, you could. That would be awesome.
I was thinking about hovercrafts too, though.
All right. I'm going to go ahead and throw this up on the board so that we can look at these together. So the idea here is, if you do the engineering design process correctly, you will have a robust list of measures of quality that really identify how well your design solves the problem. I'm gonna have to.
Okay, I saw the fan on the chopsticks. That is not a bad idea. That is a very solid idea.
All right, there it is. Okay, so
That is a good idea.
I mean,
That is a dang good idea.
is this the best thing? You have chopsticks that now weigh like 3 pounds.
That is fine. At least I'm not burning my mouth.
At least you're not burning your mouth, but it's exhausting. It's just like holding a 3-pound pair of chopsticks. Okay, I don't know if you've ever seen this.
Connect a balloon to go on the other side.
I have no idea.
There you go. Something that'll hold it up. This is to keep you clean while you're eating noodles. Problem is, you get dirty while eating noodles, so wearing a face mask keeps you clean. Talk about the fork pizza cutter. This was invented by Satan. Who eats pizza with a fork? Were you gonna raise your hand? Is that like for real you do? Okay.
If the pizza's like super floppy, that's super greasy. You want to
Okay, the grease is the only exception. But this pizza is not greasy.
It's just, how would you hold that fork?
There you go. You get a spoon, not a fork. Oh yeah. This way.
Yeah, heck yeah, I would never get off the toilet.
Yeah. Just make sure to sanitize that thing when you're done.
Nope.
Oh, here you go. You don't want your feet to get wet. High heel umbrellas. Sweetheart, sweet shirt. That way you can be tied to your lover forever. Only $79 for basically shackles. It's like a glue stick with butter. That's amazing.
That's how you get really precise butter on your bread.
That's right. It's for the people who are really meticulous about their cooking.
I like that one. I would wear that.
This way, if you want to TP somebody's house, you can just throw your kids into the trees.
Wow. I love that you thought about that. That's the kids that we throw.
I like the car. Looks like it's going places.
That's awesome. I like the meme. Meme is great. Oh yeah, the pet rock. You can pay for a rock.
Can you go up to the glass?
Yes.
Huh?
Can you go up to the glass?
Pet rock. Only if you're willing to feed it.
I'll pay for it. That's an incredible invention.
Look at the guy's face. He's just very into like, yeah, haircut, yeah, heck yeah.
He is the UFO.
I like the red gloves.
There you go.
Red gloves. Yes.
What?
Make anything into a sandwich.
Yes.
Let's see. What? Soup with cracker container.
It's actually not a bad idea.
It's interesting, but is this the most effective? What in the what?
Yep. How much?
Yeah, I want a food tray on my steering wheel. Heck yeah. So once again, if you apply the measures of quality to any of these devices, this is why it doesn't work.
There's gotta be better ones.
Hold on, before you leave, I gotta show you the personal sauna.
Personal sauna.
You just breathe heavily in the bathroom.
Where is it? Oh, the portable sauna.
That would work really well for us.
See, where's
It's not here.
here we go. Yeah, because
Want
he's,
more from your shampoo? The Suave Professionals collection, infused with the finest ingredients, gently cleanses every day. For salon quality hair you'll love. Get more out of your shampoo with Suave Professionals collection.
If they were like, fire alarm starts going off and you're like, what? You'd be like, oh no.
Today, I'm going to be trying a portable steam sauna. Don't know exactly what that means, but I know I'm probably going to get really sweaty.
I feel like you guys are going to put me in a makeshift spa castle, kind of little like Amazon Prime.
I like saunas. I like anything hot. hot tubs, saunas, I love them all.
I love saunas.
I don't want to hear you
love-
talk about saunas.
Break this down and build.
They're supposed to be really easy to assemble. They are not.
Do you have one?
No.
Go in and take off my pants.
Although I should get one just for the sake of saying I have one.
So, excuse me, guys.
On Wednesday.
Yay.
So I will not see you on Wednesday.
So are we supposed to do anything or?
Show up on Friday.
Great.
All right, I'll see you then. Yeah.
Friday?
I posted a video online for a lecture. You can go back and watch that.
And then just do the quiz.
Yep.
Appreciate it.
I'm not trying to rush.
Hey, you need to hand in your project one paper still.
I didn't turn it in.
I don't have a paper from you.
Okay.
And Ivana, I don't have a paper from you either. For project one.
Really?
Yes.